welcome to second semester Algebra 1. Since I probably am not going to be here tomorrow, I'm going to do ratio and proportion in one video, and if you'd like to work ahead, you can. Obviously, most of this is a review. So we all know that a ratio is a comparison of numbers using division. The way we're used to seeing it, there's a couple of different ways we could write it. 32 to 48. Okay, and always you need to simplify, so you look for the greatest common factor and divide by that. In this case it's 16, but probably most of you would see 8 first. 32 divided by 8 is 4, 2, 6, which simplifies to 2 to 3, because actually 16 is the biggest thing that goes into both. Let's make that neater. Okay. 48. Okay. So we can use this too. We can also use the colon, 25x to 20x. Now, to say simplifying, that's just really fancy for reducing the fraction. So we are, although you haven't seen many variables when we've talked about ratio before, this means 25x to 20x. The x's cancel out, and this leaves a ratio of 5 to 4. The final way, and the way that we're going to be using this most frequently, is to show a fraction. 9x squared y over 6xy squared. And just like we were doing in the last chapter, and by the way, this whole chapter is about applying fractions, so this is 3x over 2y, because there's an x left up here and a y left down there. That's all very simple. As we know from before, this can get a little bit more complicated when the things are in different units. If I have 3 hours to 15 minutes, I have to first change them so they're always in the same unit. You always want to use the unit that's smaller. Minutes is smaller than hours, so you can convert hours to minutes without using fractions. We all know there are 60 minutes in every hour, meaning there are 180 minutes in 3 hours over 15. Now, most of you might not immediately realize that 15 goes into 180, but we do know that 15 minutes goes into 3 hours. However, I imagine a lot of you would see that 3 is a factor of each of these, and then that reduces to 12. This is one thing that's different about ratios than fractions. We actually need this one, because a comparison of numbers needs a number. Now, I know also that there are some units that you're a little familiar with. In your homework for this unit, you need to know how many ounces are in a pound. So 16 ounces equals 1 pound. You also need to know, oh, I guess you don't need to know quarts, but in case you're ever asked, there are 4 quarts to every gallon. But much more significantly, we have the decimal system. So let's try to lay this out once and for all in a way that helps you see the comparisons. It's just like our place value system. The prefixes are kilo, and that's for 1,000, the 1,000 place value. Hecto, which is the hundreds. I hope I have enough room to write this. We have deca with a K, which is the tens. Then we have the units, which could be meters, liters, or grams, depending on what we're measuring. Then we have, those are the ones. Then we have deci, which are the tenths, and for a reason I'm going to write that as a fraction. Also, we could write it as a decimal. And then we're going to call the centi, which is 1/100th. So if you think about this unit, this is where it all revolves around. To get from centi to 1, we have to multiply it by 100. So there are 100 centimeters in a unit, a meter. To get from the meters to kilometers, we have to multiply by 1,000. So there are 1,000 kilometers or kilos for every unit. Those are the most frequent kinds of things. But let's say that the problem wants to know how to get from centimeters up to kilometers. If you look at it, if you have this in mind, you can see that if I have to go first to 1, that gives me the units. This equals 1. And then from 1, I have to then also multiply by 1,000. So 1,000 times 100 is a 1 with how many zeros? 1, 2, 3, 4, 5. So there are 100,000 centimeters in a kilometer. If I want to go the other way, I have to divide. To get from 1,000 kilometers to 1, I have to, I guess I have to on my next slide, to get from 1,000 to 1, I have to divide by 1,000. Okay? So 1, and if I would have to do it here too. So there are there's 1,000th, or there is 1/1,000th of a unit of a kilometer in a unit. Or since I'm doing kilometers, I will call this the meter. And if I have to divide this by 1,000, I divide this by 1,000, meaning there's that. So if you use that little sliding scale, you should be able to convert any metric unit from one way to another. Think about getting to 1 first, and then from that, moving to whatever beyond 1 in either direction you're trying to go. So the other thing that comes up in these kinds of problems are the classic word problems. And I would have you refer to page 288, example 5, so I don't have to write every single thing down. But essentially, 160 acres are being planted in a ratio of 3 acres of alfalfa for every 5 acres of wheat. I think from problems of the day and SSAT prep and whatnot, you pretty much know how to do these, the shortcut. But I'm going to show you the algebra that goes with that. Anything that's in a ratio of 3 to 5 means that if you reduce an original fraction, you will get 3 to 5. So what I mean by that is 9 to 15 is in a ratio of 3 to 5 because I multiplied the top and the bottom by the same number. I could say 15 to 25 because that would be 3 over 5 times 5 times 5. As long as I'm multiplying the top and the bottom by the same number, I'm really just multiplying by 1, and so I'm getting a different form. Whoops. So these are both numbers that are in a ratio of 3 to 5. Well, in this particular problem, we don't know how many acres of alfalfa or how many acres of wheat. We just know that they are in a ratio of 3 to 5. If they're in a ratio of 3 to 5, what that means is that just like here and here, they're being multiplied by the same number. Whenever where we know the number is the same, we don't know what it is, we can call that number x. That's what makes this algebra. The other thing we know about this problem is there is a total of 160 acres. So however many alfalfa acres there are, added to the number of wheat acres, is going to add up to 160, meaning 8x equals 160, and that means that x is 20. If I know that x is 20, then 3x is 60, and 5x is 100. These numbers are in a ratio of 3 to 5, and they do add up to 160. I think this is why the whole idea of adding the 3 and the 5, dividing it 160 by that number, and then multiplying works. So you're going to see several word problems like that as well. So let's move on to the notion of proportions. We have used proportions so often, but proportions are simply equal ratios. And we know that whenever we have equal ratios, let's just take that last problem we did. 3 over 5 is the same as 6 over 10. We know these are equal ratios. Whenever that's true, the top of one times the bottom of the other is equal to the top of one times the bottom of the other. In this problem, 30 equals 30. So A is to B as C is to D. Whenever that's true, A times D equals B times C. In the beginning, the problems that you have are going to be just like what you've always done. If I say 3 is to x as 5 is to 4, you're going to say 3 times 4 is 12, and that equals 5 times x, and you're going to divide by 5. And notice they don't always come out evenly. So the answer to this is actually 12 over 5. You don't need to simplify, but if you did, it would be 2.4 or 2 2/5. Any way you look at it, it's like that. Here's one that's slightly harder. This is example 1. Well, here's one that's slightly harder only in that if 3 over n is equal to 8, in order to do this, we need to put in a 1 here so that we have something to cross multiply. So we know that 3 is equal to 8n, making n equal to 3/8. Now they get a little bit more complicated, as always happens in algebra, but this principle is exactly the same. X minus 4 over 3 is equal to 2 over 15. I'm still going to cross multiply. Remember, put your polynomials in parentheses. 15 times x minus 4 is equal to 6. I'm just cross multiplying. So 15x minus 60 is equal to 6. When I add the 60, I get 15x is equal to 66. Divide by 15, and I always have to then reduce. Always. Always, always, always. X equals 22 over 5. The same exact principle. You just need to know to put your polynomials in parentheses. One thing I do want to point out is that there are problems on your homework that become much, much easier if you first simplify. If you notice that one of the sides can be simplified, then you need to do so. For example, if the problem is 18, you don't need to, it just makes it much easier. 18x over 13 is equal to 36 over 39. I hope that you would realize that these two are both divisible by 3. That makes this problem 18x over 13. If I simplify this fraction first, I get 12/13. Now, I could then, that's easier than multiplying 18x by 39 and 36 by 13. But in this situation, since these denominators are the same, that means that 18x equals 12. So x is equal to 2/3. Just like if I said, how many thirds are 2/3? Well, obviously x has to be 2. That's the reasoning behind what I just did here. The point is, and simplify up front, you often get much smaller numbers. So I'm not going to do any more of those, but I would say every single time you look at a fraction, at a proportion, if you can simplify one side first, you want to do that. The final thing that comes up in proportion problems is, of course, word problems. Word problems with proportions are quite straightforward for the most part. The one place that people often get mixed up is if you don't keep track of what you're putting on the top and what you're putting on the bottom. So my suggestion to you is to write down in words, make a word ratio so that you can keep that straight. I would like you to look at example 3 on page 294, so I don't have to set the whole thing up. And if you don't have that right now, you can pause this and go find a book. It says, with a 5-pound bag of flour, the cooking class can make 120 date nut muffins. How many muffins can they make with a 2-pound bag of flour? So it's pounds of flour to muffins is what we're comparing. Just like when we're doing the percent proportions, we have to keep the part to the whole. And in fact, we will be doing some percent things here. So we know, we're given that 5-pound bag of flour makes 120 date nut muffins. How many muffins, that means it goes on the bottom, can be made with 2 pounds? Okay, now first of all, we know we can do this and we can do this. I do want to point out, though, that we can also see that 5 goes into 120. And so if I wanted to, I could first do what I was just saying and simplify a fraction. We could call this 1 over 24 is equal to 2 over x. And you can easily see then, without even doing any math, that the answer here is going to be 48. That's what you would get if you did this. Or if you did the work for this one, which would be 5x is equal to 240. And when you do this, you would find out that x is equal to 48. So that's that.